Hey folks, this is 10.3. We're working with circles and equations of circles, or in a little bit equations of tangents. Given the following equations, state the radius of the circle and graph the equation. So remember, when we have x squared plus y squared, that equals the radius squared. So that means that 4 squared gives us 16, so the radius equals 4. And the center here is at 0, 0 for this lesson because it's just x squared and y squared. In the future, you might see how that could get moved about. In fact, we know how to do adjustments, but we're just trying to limit what's in this section. So there's a circle about the center of 0, 0 with a radius of 4. That is beautiful. Using the same concept for number 1 as number 1 and number 2. 11 must be the radius because 11 squared is 121. So the radius is 11. Center is at 0, 0, 0, so there's the center, 11, 11, negative 11 would be a distance of 11 from 0, 0, and so would that negative 11. So then just try to make a curvy swervy. Oh boy. Oh, got a little shaky at the end there. What else? Make sure you can see those dots. Like, it'd be good that on your test that you can, like, us teachers can clearly see that you're trying to hit those 4 points, that you know what a radius of 11 looks like. Number 3. What's different about that versus our template that we see of x squared plus y squared equals r squared? Well, all the x's and the y's each have a 3 in front of them. So what we want to do is distribute a 1/3 or divide everything by 3. Multiplying by 1/3 is the same as dividing by 3. So essentially I'm taking a third of this, a third of that, which gives me an x squared and a y squared. But to keep the equation equal, I have to do that to the right side as well. So when I take this, I get x squared, a third of 3y squared is just y squared, and a third, or 27 divided by 3, is 9. So that 9 is in place of my r squared, so that means that my radius is 3. So from 0, 0, we go out 3 units in each direction and make a circle through them. Number 4, what's different about that equation than this template? Well, there's a couple things. There's coefficients in front of the x and the y squared. That's a problem. We'll deal with that in a little bit. But also, the y squared is supposed to be with the x squared. So I'm going to add 4y squared to each side to get the x and the y on the same side. So we get 4x squared plus 4y squared equals 144. How do we get rid of that 4 in front of the x and the y? We multiply by 1/4. Again, it's the same as dividing by 4. So we get x squared plus y squared equals 36. Because a fourth of 144 is 36. So what is our radius? It's the square root of 36. Our radius is 6. So let's go up 6, right 6, down 6, left 6, and put a circle through them. Whoa. It's a funny looking circle. Number 5, 6, and 7. Write the standard form equation of a circle that passes through the given point with a center at 0, 0. So I'd recommend that you make a decent sketch here, folks. So here's my origin. Ooh, that's not a good start. You'll see why. I need to go out 8 to the left because x is negative 1. So the circle goes through the center of 0, 0, but we know that a point on the circle is negative 8, 1, which would be right there. So I guess from here I can kind of sketch a circle. Something like that. What we need to know, we already know the center, so we know it's going to be x squared plus y squared equals the radius. We use this location that is actually the only one location we know that's on the circle to find the radius. So the radius is going to be the distance of this line right there to the center. That's the sprinkler length. Well, to get that, I don't know the length of a diagonal line. So I could make a right triangle. Ooh, I shouldn't have used red with red on that dot. There's the point -8, 1. How long is that black line? Well, we could use the distance formula, which is also the Pythagorean theorem. So we're comparing the distance from -8, 1 to 0, 0. So if I use the distance formula, again, it's this whole x minus x squared plus y minus y squared, all being square rooted. That's where our distance is, or our length is. In this case, the distance is the length of the radius. Well, what's the distance between -8 and 0? It's 8. This length is 8, so we're going to square that. What's the distance between 0 and 1? That's 1, so we're going to square +1. And then we're going to square root all of that. So we get the square root of 65. That's what the radius is. Really, you're doing the Pythagorean theorem. Your A is 1, your B is 8, and then your C is the answer, but we need to square root. I'll just show you real quick. A squared plus B squared equals C squared. We have 1 and 8 squared equals C squared. So C squared equals 65. And then to get C by itself, the length of the hypotenuse, we have to square root. So we get the square root of 65. I don't care how you do it, as long as you show me a little bit of work what you're doing. Now, careful. Our equation is going to be x squared plus y squared equals the radius squared. So now I need to take this radius and I need to square it. And what does squaring and square rooting do? They cancel each other out. So the radius, the value that I'm going to plug in for this r squared is 65. So we have x squared plus y squared equals 65. Let's try that on the other ones. I'm going to go a little bit faster here because, again, we also have the point 0, 0. I should make a sketch. So from here,